Welcome to January 3rd's LeetCode challenge. Delete columns to make sorted. You're given an array of n strings, all the same length. The strings can be arranged such that there's one on each line, making a grid. For example, you have the strings of the array containing ABC, followed by BCE, followed by CAE. Can be arranged as the following, right? We have ABC, BCE, and CAE. Given as such, that's how you want to visualize it. If you want to delete the column that is not sorted lexicographically, in the above a zero example, you have zero index, so basically the zeroth column being containing all of the elements A, B, and C, and the second being C, E, and E going downwards, while the are sorted, while column 1 being BCA is not sorted, so you want to delete the column. So basically return the number of columns you need to delete. So in this example, you would just delete 1 because ABC going down in terms of column is sorted, CE is sorted, but BCA is not sorted. And that's pretty much it. So we're given the strings as such. If we were to visualize it in a grid, it will look as the following. And we know that columns 0 index and 2 index are sorted. Therefore, we have to delete the middle column. Column number 1 is not sorted. Therefore, we delete one column. And we have basically AB, and only has basically a 1 by 2 matrix. Therefore, we have one column 0 being it is sorted, so we delete 0 columns. And similarly, in here, all 3 columns are not sorted, therefore delete all 3. So the constraints are that the string length is equal to n, and n is between 1 to 100. The length of each index of the string is between 1 to 1,000, and the index of the string consists of lowercase English letters. Alright, so far, it seems like we have a matrix traversal type of question. So say we have n strings, and each of them the same length, say given k. If we make the grid or the matrix using the string one of each line, then we find out that the column of the matrix is not lexicographically in order. However, we note in this example here that the grid or the matrix is not an n by n matrix, so it could be of any, I guess, dimensions. We just need to find the columns to make sure that they're lexicographically sorted. So in order to be in lexicographic order, each character of the column must be equal or greater than the corresponding character in the previous row. So therefore, we need to basically iterate through the columns. For each column, we iterate through the rows from index at 1, not 0, as you compare to characters in the previous rows. Then we figure out that there's kind of 3 cases we want to think of, right? So it could either be sorted or unsorted. So let's develop an algorithm that basically iterates through the column from, say, 0, index 0 to k minus 1 for each column. And then within each column, we iterate through each row from 1 to n minus 1. If the character index is in the column and the index of the row is smaller than the index character of the index of the column, therefore we have to increment our answer to see if we have to delete that that row or not. And we just basically return the answer. So let's kind of implement that. So I'll write some comments. So the string length should be that much. So therefore we define an integer called k. So we will have n, and we use n2, I guess, numbers array. We'll call it k because n signifies the number of elements inside the string array, so we don't want to get that. It's not really the same thing, but so we'll define it as k here, and then we find the length of that. I'll be solving this in Java. Next thing we want to do is basically find a variable to store the answer for it to be deleted. So basically define a variable, I don't need to define, I'll write down variable to return the count of columns to be deleted. So this is going to be int, we'll call it our output, and that's going to be assigned to 0. Next thing you want to do is iterate over each index in the string. In order to do that, we develop a for loop, int column equals 0, such that we have column less than k. We increment column by 1, or increment column, and then we iterate through over the strings. And for int rows, and we iterate through the rows before it, so therefore we have to start at 1. If where row is less than the string's length, where we increment row by 1. Alright, so far we iterate through. Now we check for each character should be in increasing order. So it should be lexicographically sorted in increasing order. And do that if otherwise increment the counter. Increment the counter. So if the string in index row and we want to find the character at the index column is less than the string at row minus 1, so the column the row before it, and we need to find the character at that point as well. Char at the column. If that's the case, we increment our answer or output by 1, and then we break out of this. Alright, we get out of this loop, and this is the loop. Once we have iterated through each row for each column, that means we've gone through the entire matrix, and we basically have incremented the output whenever this condition is true. So therefore it is all sorted, and when we exit that loop, we just return our output. And this should work. Of course. I'm going to be running a lot of syntax error in the near future because I'm switching over from Python, so excellent. Alright, accepted. It's not the most fastest algorithm, but so complexity analysis wise, we have time complexity of big of n, k times n. Since we're iterating through over each character and all the n strings, though we break in the case that we do break out of it if final column is unsorted. However, in the worst case, if there's no unsorted column, then we have to iterate through each of the row for each column as well. So hence the total time complexity at worst case is big of n times k, where n is the number of strings given in the string list and k is the length of each string. Space complexity, we don't really need any extra space complexity aside from the variable output. used to store the count of unsorted columns, so therefore we have a constant space complexity. And that is it. Have a great day, guys.